Okay, we're looking at functions in this tutorial for week 3. If you're following along, you can start on the web page, look at tutorials, week 3, and we're going to talk about functions. This is going to be very short and it's conceptual. Now, so far, every program we've been writing and looking at in class and for the tutorials and the assessments has had a main function, all right? And we've been putting stuff inside of main to do work for us. That hasn't been a problem. But, you know, if you add a lot of stuff and have a big main program, it can become unwieldy to read. It can be hard to debug. It can be hard to add functionality. And best practice is if you have a task, especially one that's going to happen more than once, you would write a function, write your own function to do that work. The way that I think of functions is they're bits of code that do work for us. And usually we have some input. If there's a void function, there is no input required. It just does that work. There's at least one output for every function. You know, the very least output, you can read the notes if you want to get into this in a little bit more depth, is whether or not there's a correct execution. All right, so thinking in this way and working in this way hasn't been a problem yet. All the programs have been super simple, but if they start to become bigger, we need to do something about it. Well, C and every programming language allows you to define your own functions, write your own functions. And, you know, sometimes there's different jargon with them, but they're all exactly the same. Some languages might refer to them as procedures or methods or subroutines, but they're functions. Functions do work, and you design them to be modular. All right, let's see what they're all about. Well, we think of a function as a black box. This is a metaphor for functions, and we'll explain that with after a couple of examples here. I mentioned that it has 0 plus possibly more inputs and at least the one output. Well, you know, maybe we'd have this black box function just totally generic. We have 3 inputs, A, B, and C. We put in A, B, and C. Maybe they're strings, and we get out something else. We get out a Z. But, you know, maybe we name that function add, and the 3 inputs are integers, and we add them up. 3, 6, and 7 add up to 16. The input, integers. The output, the result of some work. We've added those integers together. Likewise, maybe we have one called multiply. Maybe it's got 2 arguments, and we submit 4 and 5. 4 times 5 is 20. The inputs, integers, or possibly floats, and the output is after the multiplication function, the mult function does some work for us, 20. All right, so why do we call the function a black box? This is a bit of a tradition / a way of thinking philosophically about what's happening here, if you will. We aren't really writing some functions ourselves, and if we're not, you know, we've used loads of functions somebody else has written by calling those headers and implementing them, maybe reading the manual. I hope you've looked at the manual pages to give you an idea of what happens inside the black box, specifically with reference to the output. And you know what? If we're not writing the functions ourselves, we do not need to see the contents of the function. Sometimes it might be interesting too, as a learning or to understand what the output is doing or how to get a particular output that's desirable. But we don't have to. We don't have to see what's inside the function. What we can do instead is, and this is just even a slightly more complicated example up to there, you know, this goes up to very, very complicated examples. Here, you know, we can see set the counter to 0, repeat B times, add A to the counter, output the counter. You know, we don't have to know this to read a function, the name being mult, guess that it multiplies some integers, and if we see the definition of how many arguments there are, we could easily figure out how to use that function effectively itself. So, you know, philosophically, that's part of the contract. You're using the function. The behavior can be predicted on the name, and at worst, you know, we refer to the manual. A lot of times, the hardest part of using a function is discovering that it exists. And if you can think that something simple should exist, trust me, it's just a matter of finding which one. And because the name, the convention of this is such that the writer of the function adheres to the user contract of naming the function something sensible. You can often guess the function functionality that there is just from the name, and that's why we have documentation as well when it's not so clear. So why do we use functions? Well, organization. We break up complicated problems into smaller building blocks that are very simple. The simplification is another motivation explicitly. Smaller components tend to break less. They tend to be easier to implement, tends to be easier to find out what the problem is if you need to. And then reusability. You tend to write the largest number of functions for your own use, but sometimes if you write something really good, you'll get to the point where you may want to share it with other people. You're solving your problem primarily, but if it's a common enough problem that hasn't been solved specifically somewhere else, share it. You would add your function to a package and let others use it. And that's all there is to functions, and that's all I have to say about that.